Dear ladies and gentlemen, we very much welcome you to the next 10 minutes of presentation on testing of companion specifications. We are Labs Network Industrie 4.0, a pre-competitive and non-profit association based in Germany, and the University of Applied Science in Ravensburg, Weingarten, which is in the southern part of Germany. Industrie 4.0, or smart manufacturing, is orchestrated and organized in form of a platform in Germany since the year 2015. It follows three goals. Number one is interoperability that covers the regulatory and standardization aspects. The second goal is autonomy and sovereignty that includes trustworthiness and IT security topics. And the third aspect is sustainability, which includes good work and climate change. In Germany, we have quite a complex setup for Industry 4.0, which I will explain in this slide. It is separated in two parts. The upper part is the top-down approach, and the lower part is the bottom-up approach to Industry 4.0. Top-down, we see the VDMA, our host today, which is the Association of Machine Builders. But in addition, we also are having input from the Association of Electrical Engineers, CVI, and the Software Association, Bitkom. They are orchestrating, together with many other partners from industry, academia, etc., the platform which has two tasks. Number one is internationalization, focuses on European Union on one side, and America, China, Japan, Korea, India, and some others on the other side. The second goal or the second task is to operationalize and keep updated the library for Industry 4.0 publications, which includes primarily interoperability documents. On the lower part of that slide, you see on the bottom right the pre-competitive and non-profit neutral association LNI 4.0 that I present you here today. My name is Dominik Rohrmus. I'm the CTO of this association. We do use cases in the area of Industry 4.0 with a focus on interoperability, primarily with small, medium enterprises. So we try to put everything in place and support the transformation of small, medium enterprises in the industrial area. We do it together with the Chambers of Commerce and some other operations. We transfer the results and the findings of this testing, of this use cases, of these test beds to the bottom left part, which is operationalized by the Standardization Council Industry 4.0, and as the name says, takes care of standardization and normative activities. Normative is extremely important for OT, for operational technology, for factory, for production. And on a global scale, ISO and IEC are the organizations that take care that those norms are globally, and that means in 176 countries, available and compliant. On the left side, we come more from the IT area, where OPC Foundation and many others can be found, like IEEE. The standardization has to come closer to the normative, and the normative activities have to come closer to standardization. This is the main goal of Industry 4.0 and one success paths that we have to go. By the way, normative is basically fully consensus-based standardization. That is how it can be described. And why is this so important? We want to plug, so basically browse and find our assets, our devices, our technologies everywhere. This shall be possible without any restrictions. This is the lower part of that picture. So for that we need norms and standards so that we can find them even if we don't know them at the beginning. However, when we utilize the devices, the technologies, we want to be in the free market. We want to play these assets. This is beyond normative and standardization. The testbed that I present you now is finding exactly that borderline where normative should start or stop and where the free market will begin. And how do we do that? In Germany, we are in the situation that we have so-called competence centers 4.0 and testing facilities or labs like Weingarten, the University of Applied Science, which is our host for this testbed. In this testbed, we follow the goals that I mentioned already that I would like to elaborate a little bit more on. We are gaming aiming at multi-vendor interoperability. This is the overall goal among all assets at as little cost as possible. And we operationalize that based on use cases. Primarily use cases coming from small, medium enterprises like system integrators, small production facilities, engineering departments, and comparable. We are using demonstrators, and I will present you that demonstrator in a couple of minutes to support and to show that these companion specifications are functioning correctly, that testing takes place, and that we can build machines and devices based on those companion specifications. The overall goal is certainly the validation of standards and standardization and to support that. For this, we have the vehicle of liaison contracts with the most relevant global standardization bodies, and by that we are able to compliant read draft documents and comment on them. Now I come to the demonstrator of the testbed. The testbed on companion specifications. And in this demonstrator, we show that multi-vendor interoperability based on node set files is possible and can be operated. On the top left, you see the demonstrator as it is right now. So you see a robot and a table with several devices to be handled, and we have in this demonstrator a robot. Then we have auto ID technology, which in our case is an RFID, and all the devices to be handled have an individual RFID tag. And then we have for the inspection part 2 scales. So again, the multi-vendor situation. And exactly that will be presented in more detail by the presentation directly after my presentation by Eugen Schiebli from Mettler Toledo. And in addition, in the future, we will have a vision system for additional inspection, all connected by companion specifications. On the upper part, we see the control and the human-machine interface, also connected by companion specifications. However, connected might not be the right term. Better made interoperable with the other devices by companion specifications. And later on, we will have a direct connection to an ERP system. This testbed and this demonstrator enables us to plug and to play and to handle all these companion specifications and to check out how they work and how it is done best. This is exactly what it is about. We have now a neutral, free thing, a device, a demonstrator, where we can play around as we want and try out, do the system integration parts, do later on the connection to the engineering over the entire life cycle. And this is exactly what we want to show here. It is about presenting, demonstrating, trying out in a neutral environment, like on the play field of companion specifications. And with this slide, I want to invite you to this open and neutral testbed hosted by Weingarten, where you can try out your technologies without any obstacles. But there's something in addition. There's a broader topic in the back. There is also the so-called asset administration shell, and the companion specifications are in the center part of that asset administration shell. They are so-called submodels. So each companion specification is also almost automatically, there's a binding necessary, a submodel of the asset administration shell. And with this asset administration shell, we are also on a global scale, and we enable interoperability among and beyond the domains that we usually talk about, also here in the VDMA, covering all other domains that you can think of. All are represented by asset administration shells. One example could be connectivity. So a 5G network has also a representation in an asset administration shell, and by that the services can be booked or addressed. This is summarized in my final slide here. On the left side you see that asset administration shell as the global interoperability standard, which is standardized in a normative way in IEC. And on the right side, you see companion specifications over the entire life cycle that are covering in this part here now the area of the VDMA activities, and also broaden them themselves towards connectivity, as you can see on the left-hand side. Those companion specifications are necessary to describe semantically information that in the old days were only accessible by manual operations. Thank you very much, and it is my pleasure to hand over now to the specific part of companion specifications in the area of scales, which are already demonstrated in the demonstrator I just presented to you. So I hand over now to Eugen Schiebli, and I again welcome you all to the open and neutral testbed. Just come and play and try out with us together.